All right, I believe we are live. Hello, everyone. Thank you very much for coming. My name is David Awad. I am one of the wonderful developer evangelists here at R3. Happy to chat with you guys today. It should be a good time. We're going to do basically a quick developer bootcamp. We're going to work together to build a CorDapp and talk about the basic concepts you need to understand so that you can then take your own ideas and build prototypes of them using Corda blockchain. So, hopefully all that makes sense. I'm going to start just by dropping a quick link in the YouTube chat, and I'll also ask a quick question just to see if you guys, what your basic kind of familiarity is with blockchain. If you could just start by typing a quick 1, 2, or 3 in the chat, just to outline for us what's your familiarity with blockchain. 1 being very new, and 3 being an advanced or kind of very experienced blockchain user. Just so it's just a good poll so we can get a sense of who we're kind of looking for. And as you just saw in the chat, my colleague Peter will be also from the DevRel team. My colleague Peter will be there backing me up. So if you have any questions whatsoever, feel free to post them in the chat and Peter will answer them. And I think that is everything as far as preamble from me. So I think we can just get started. So I will jump into the slides. Whoops, there we go. All right, so for starters, you can find us here on YouTube or on Slack. Our documentation is pretty solid. We have a free training site you can also check out. Corda is open source. You can email us online at devrel@r3.com. And of course, we are on Twitter at InsideR3 and at Corda Blockchain with the various hashtags. So please do feel free to reach out to us if you need anything. So just to get us started here with the basics, right? The first question to really ask here is, what is a CorDapp? And so a CorDapp essentially is a Corda decentralized application. Now what that means is it's essentially an app that runs on a distributed computing system. We also sometimes refer to them as smart contracts or code running on top of a blockchain transaction, which can be really powerful. So your applications are pretty much anything that runs, let's say, for managing a particular negotiated rate of internet bandwidth, that something that a computer can track and kind of enforce within the actual transaction itself. And we'll get more specific as far as what we mean as we go. So to bring it back to CorDapps, and the literal level, these are just binary jar files that are stored on top of machines that are running the Corda application, right? So each node can actually carry multiple CorDapps. All you have to do to install one is, after you've built one, you will compile it into a jar file and copy it onto that machine. And that's all it takes. So you can have, for example, a supply chain app running on your node and have an insurance CorDapp running at the same time. So all of that being said, I just want to outline for you the 3 basic components of a CorDapp. There are states, contracts, and flows. So states are the objects themselves. Contracts verify the validity of the transactions or the things that you can do with those objects, right? And then flows are the actual process of triggering transactions or executing the business logic around the particular transaction you're using or doing. So that being said, Corda uses an unspent transaction output model for its blockchain, meaning that states or objects are created, they get consumed, and they get stored. And those are the basics. So our goal, right, is we're going to create a token CorDapp that showcases the issuance of a token on the blockchain. So we're going to implement 3 files, right? We're going to implement a state, a contract, and a flow. So the first will be our CorDapp, and I'm going to call it 723 Bootcamp, just to have a unique name here. So now that I've got that, I'm going to open up IntelliJ, and I'm going to hit open to make sure I open this project I've just cloned. It should take me right to the desktop, and I'll just clone this or open this 723 Bootcamp folder. We'll see how that goes. There's a little bit of configuration we'll have to do with IntelliJ, and I'll show you all of that in just a second. So the first thing you're going to see This is actually right underneath where I'm sitting. So let me see if I can shift out of the way a little bit. You'll see a little pop-up right about here that says IntelliJ found a Gradle build script and to import the project. So I'm just going to click that. That's the only pop-up that'll be down there, so I can rotate my way back over here. And you'll see over here that we just got some Gradle configuration options. So I'm going to just move my windows around a little bit and wait for the Gradle build to complete. That shouldn't take too long. So while that's going, we're going to make 3 quick settings changes just to make sure you're using the right version of Java. We're going to go into the project structure, which you can find with command semicolon if you're on a Mac. But we're going to go to the project structure settings, and we're going to change this to Java version 1.8. And we're going to set the language level to 8 as well. Nothing crazy there. So I'm going to hit apply and then hit OK. Great. So that hopefully just worked, and now our Gradle build file will not complain about the Java 1.8 version. Then we're going to do one other thing inside of the Gradle specific settings. There's one more place where we have to tell Gradle that we want to use Java 8, and that is inside of the Gradle JVM segment. Inside of preferences, you can see this little window if you click the Gradle elephant on the right side there. And so we're going to click that wrench right over here to the preferences. We're going to go down to 1.8. So I'm going to hit OK. I'm going to hit Enable Auto Import. That's also down here, right here somewhere. I'm just going to go and enable Auto Import so that the all of the correct prereqs get downloaded, and hopefully Gradle is able to make this happen for us. Maybe we'll get lucky. So while that's going, I'm finally going to open up the state file that I was telling you guys about. Inside of source, main, Java, Bootcamp, and we see 4 files here. I'm going to start with token state. And since we're good test-driven developers here, we're also going to talk a little bit about test. Looks like our configuration was successful, so that's good. We're also going to talk and start with flow tests. So inside of here, we have a few different tests for what we're trying to accomplish with this file. Now, inside of our state, like I was talking about earlier, we have an issuer, an owner, and an amount, right? So inside of our state, these are the only things we really need to encode. So to get to that point, I'm just going to jump into IntelliJ and type this out. But the tests that we have are going to ensure those basic things. For example, ensure that the token state has issuer and owner amount. Nothing too surprising there. And then it takes Alice and Bob. And we'll do other tests around the same idea. We'll assert that the token state, if we pass 1, is an instance of contract state, which we'll talk about in a minute. And we do some other verifications of some getters and setters. So let's actually go and implement this now. The first thing we have to do is specify that our token state actually has a decorator, that it belongs to tokenContract.class, which we haven't written just yet, but we'll talk about that in just a moment. So our token state actually implements the contract state abstraction provided to you by Corda, which is an important distinction, and it's going to come in handy when we start implementing some of these methods with respect to how Corda handles the communication for you between your node and other Corda nodes run by other people. So we're going to start with the basics, the private final party, and I'm going to have issuer, right? This is the person who issues the token. Then we're going to have the owner, right? I issue a token to somebody else, so they're the owner. Then I'm going to have an integer, which is the amount. And then I'm going to have a Corda abstraction, which is going to be a list of abstract party. And this is going to be called participants. Now this is referring to the participants of the transaction, just for clarity. So let's start with our constructor, token state. We're going to have a party issuer and a party owner and an int amount. So these are the 3 things that we need in order to create our token state. So I'm just going to set the member variables for now. This dot issuer equals issuer. Whoops. This dot owner equals owner. This should be capital. No, it should not. I don't know why I did that. There we go. Then I'm just going to do the same thing for int. Amount. Can't type today. There we go. All right. And then we're going to do the same thing for participants, where we create participants as a new array list of type. Actually, we don't need to provide that there. Yeah, that should be fine. Nice. And so in our list of participants, we're going to add the owner and the issuer. And this just makes sense, right? If there's a transaction between two people, the issuer issues something to the owner. They're both participants in the transaction. So now that that's all there, the next piece of the puzzle is going to be to actually implement the getters. So I'm just going to do that real quick. So we're going to do public party get owner. There you go. Public party get owner. That doesn't really need anything. So I'm going to return owner. That's just whatever is in this class. I'll do the same thing for the issuer. What the heck? There we go. I actually think this would look better if we did it this way. And then the last piece is going to be get amount, and that's going to be an int, and we will return the amount. There we go. So now I have the majority of our getters that are straightforward. We're going to add one more getter. This is for the Corda abstraction that we're implementing for the participants list. So I'm going to just add the I'm going to start with this public list abstract party. I'm going to call it get participants. There we go. And I'm going to call get participants. Now this will return the actual list. So return participants. There we go. Now, 2 notes about this. We're going to add the not null directive, and we're also going to add the @override directive, because this list of participants needs to always exist. There we go. Now that should be everything we need for this class. Not so painful, right? Now, if we were to run the tests now, I think we will run into a small issue because the token contract class hasn't been implemented yet. But let's see. The good news is all of our little red lines from the compiler have disappeared, so we may be getting somewhere good. I'll jump back into the slides and we can run some tests after implementing our contracts. So, back to the concept here. What we've done so far is just implement the Corda abstraction of the token state. And that, again, is just the object, any object we want to represent. In this case, it's just me, another person, and an amount of money, or an amount of currency, or some object we want to represent digitally, in this case an integer. Now, on the other side of it is the contracts. So contracts outline what we can and can't do with the objects that we have within the context of transactions. So what do I mean by that? I can build a car. I cannot build a material, let's say. Right? People do not build gold. Alchemy is not cool anymore. So I cannot build that. So my contract might say I could build a car or I could manufacture a car, but I could not manufacture gold or silver, for example. So what the contract does is we outline programmatic rules that get run at the time of the transaction. And so it is only when the input state, let's say whatever it is, my input object is treated as an input state to the transaction, and then the contract rules are run against it, and if the transaction is valid according to the contract rules, an output state is created. Hopefully that makes sense. And so if the contract is valid and the transaction is valid, then a ledger update is recorded and all of the parties involved are notified. Hey, I received money. Hey, I gave you money. We now have a record of this that neither of us can change unless we agree upon it again. So on the other side of that, of course, if a contract rule fails, if any of them fail, then the transaction is rejected and it will not happen. It's also worth pointing out, in this case, this is an issuance transaction. There's not always an input state to be consumed. You may have been wondering about that earlier, because in this case I'm issuing a new asset into the blockchain world, and so it is actually not consuming an input state. It simply is an issuance transaction. And this is just an important kind of semantic distinction, but hopefully it won't hold anyone up. So in this case, right, on an issue command, the issuer is actually a required signer. And so what that means essentially is I'm going to issue something to you. I have to sign off on that. You have to sign off on that. That kind of intuitive reasoning is what we're doing here. So the rules we're going to add to our token contract are somewhat straightforward. There's no inputs. There's only one output state, which is you having the thing that I just issued to you. The output has a specific data type within Java, right? It's a token state class. The issuer must be a required signer. The owner must be a required signer. And the owner's amount field must be positive, right? I cannot issue a negative amount of currency or really anything else. There are other times where you can use negative integers, and this is entirely up to you on your use cases. So, assuming all of that is good, I'm going to then jump back into IntelliJ and we'll start implementing. So, you now would want to jump into the token contract class, and I'm going to open up the contract tests as well. So I've outlined for you already what the majority of these tests are going to be. So I'm going to just uncomment all of these tests to make it easier for us to run them. Whoops. There we go. So if you just uncommented this and you're following along, you're probably going to see a lot of bits of red here because contract tests haven't been implemented yet. Or sorry, token contract.java hasn't been implemented yet. So these tests essentially validate what we were talking about earlier. For example, that the token contract requires one output in the transaction, that the token contract requires one command in the transaction. And we'll talk about commands in a minute. But that's what these tests are, and it's always a good practice to add, especially when you're doing CorDapp development, to add your tests beforehand because it can make it a lot faster for you to iterate. So, jumping back to token contract, we are going to do a few things here. First, you will notice that we have a string ID. This usually just has to be a unique string for any given contract. You don't have to worry about that too much. We're going to start by making sure that we implement the contract transaction. Sorry, the contract abstraction. There we go. And I will import that now to make sure that we've got the right tools for this. So, now that we've implemented the contract abstraction, we're going to need a few things. First, we're going to, you can tell here that we have the verify method. We're going to actually override that because we're implementing an interface now. And now within here, the verify method is going to actually do something very specific. You'll notice on the bottom here that we have a public interface commands, extends command data, and then we have something called issue, which implements commands. Now this actually can stay empty, but I want to point out what it is. So issue is a semantic distinction for a single type of a command, meaning a command is a distinguishing feature of a thing we can do with an object. Meaning, like I was saying before, I can issue a token, but I cannot manufacture gold, right? Like, I could issue gold to somebody that I have, or maybe I could sell gold to somebody that I have, but I cannot create new gold if I'm just a dealer somewhere, let's say. So that this issue is solely a semantic thing. You can create other ones such as class sell implements command, class purchase implements command, etc. And it's just incumbent on you to make sure you account for that in your code. And so how we do that is actually within the verify method. We're going to look at the type of transaction this is by looking specifically at the type of command, and that will outline what the code does to handle it. So let's start by just getting the command right at the outset. So we're going to do a command with parties. It's going to be of type token contract dot command. Those are the very same commands that are in here. I'm going to call it command, and I'm going to set that equal to the result of require single command, and this is going to be fed the commands object from the actual transaction itself. So we're going to call tx.getCommands and then call token contract dot commands dot class. There we go. Looks like that worked. So now that we've got the actual command itself, the next piece of the puzzle for us is going to be to actually get the inputs and the outputs to the transaction. So we can do that too. We're going to start by getting a list of contract state inputs, and then we're going to set that to tx.getInputStates. There we go. And then we're going to do the same thing for outputs, except now we're going to call it getOutputStates. And I may need to get some water in a minute. Hopefully I make it. Alright, so here is where we get to the point that I was describing earlier. We have the command, so now we can actually look at what type of command we're looking at to know what kind of transaction am I verifying for this particular state. And so we're going to do a if command.get value is an instance of token contract .commands.issue, then we have something we can use if I was not going to make typos. Is instance of what? There we go. So we're going to pass or require that and pass a function that takes a look at various aspects of the transaction that we were describing earlier. So just to jump back into the slides for what those are, here are the rules we're going to add. Let me see if I can copy these. Never mind, I cannot. Fair enough. Alright, so inside our require that, we're just going to add some rules. The first one is going to be no input states, right? So we're going to call require.using, and we're going to have a string that outlines what the condition is, and we're going to call inputs.isEmpty. So this is actually nice because if the transaction fails for any given one of these reasons, the string you pass here is what will be shown to you when that happens. So transaction must have no input states. Then we'll do the same thing, must have one output state, right? So outputs.length or .size is going to be equal to 1. Then the output must be a token state, right? That's the kind of transaction we're operating on. And on that, our conditional is just going to be to do an outputs.get 0 instance of token states. Nice. So now we've got 3. Now I'm going to actually do something to save myself some pain in the future. I'm going to go token state output is equal to outputs.get 0, and I'm going to cast it to a token state. There we go. That looks good. So now that I've got the output object, I'm just going to use it for some of my future transaction or future checks here. So the next one is going to be rule number 4. The issuer must be a required signer, which makes sense. So this one's actually going to be a little tricky to do. What we're doing here is we're going to make sure that the public, or that the correct owning key, I should say, of the issuer is a member of the required signers for the command itself. So I'm going to first do command.getSigners. Here's the keys of all of the people who are part of this transaction. And I'm going to make sure it contains output.getIssuer.getOwningKey. Now getOwningKey is a method on that party abstraction, and we're just using the getter that we wrote before inside of the token state class, this getIssuer. So hopefully that makes sense. So now that we've done that for the issuer, right, we're now going to do it on the owner side as well. Even though getting free money is nice, it's good for us to verify that the owner is a required signer no matter what. So I'm going to then call getOwner, and that should just work. And get the owning key of the owner and make sure that they're also within the list. Now the last piece of the puzzle, we're just going to make sure that the amount is positive. So I'm just going to update my description here. There we go. And in this case, you can probably expect it'll be pretty straightforward. We can use output.getAmount and just make sure it's greater than 0. And as always, it's worth pointing out again, the output here is just a token state. It's not particularly hard to reason about, and you can add all kinds of more powerful and more flexible methods. So assuming all of this goes well, then what we're going to do is we're going to return null. And if the require that method returns null, it means that there were no issues with the transaction, and so we can consider it validated. On the other side of this if, we're going to add something else that just says if we got a command that we do not recognize, right? At first we said we're looking for issue commands. If we get a command that's not an issue command, we're going to consider that invalid. So I'm going to go else throw new illegal argument exception. And we're just going to complain that we were given an unrecognized command. There we go. And I think that is everything. So let's see if we can actually run some of our tests. And if we're lucky, everything will work perfectly the first time. If only. So, when you actually jump back into IntelliJ over to, I'm going to start with the state tests, and you go to run them, you may come up against another IntelliJ setting we may have to fuddle with. That's going to just be the modules. So it's going to essentially ask for the class path. So I believe all we have to do is just go and specify 723 Bootcamp, and that should just work. Let's see what happens. Hopefully it all goes well. Should be able to see that in the, alright. Never mind. Quit unexpectedly. Interesting. JUnit version 3.8 or later expected. Huh. Let's see if it gives me the option to try those. Let me see if it gives me the option to run select the module again. I'll keep my fingers crossed. Interesting. Alright, well, I'll take that. It magically works. That's probably not great, but we'll call it what it is. So, our state tests work. Let's now double check the contract test, and if everything looks good, we can move on to flows, where we can then run a Corda node and actually trigger the updates we want. So, inside the contract tests, I'm just going to jump into the top left here. I'm going to click these arrows and I'm going to go run contract tests. It'll ask me for the module again, so I'm just going to go for 723 Bootcamp. I'm going to hit apply and then run. Let's see what happens. Interesting. So we get the same test framework complaint, and maybe if I run it again, it'll work. Let's see. It should be right over there, actually. This may take a little while, so we'll wait on it and see if we can jump back and see how these did in a few minutes. So I'll jump back into PowerPoint and talk to you guys a little bit about flows. So I've sort of danced around this because we describe Corda as a distributed ledger technology, but we don't actually explicitly outline how this is happening and how many things Corda is really doing for you. And this is where flows really start to shine. Because what flows do is they execute the business logic between the initiator of a transaction and one or more responders. And how that happens is through node A, node B, any others, and the flow framework mediating the transactions between them along with the notaries that also validate the transactions. So I'll just outline this really quickly. Flows execute your business logic, right? And there are two main abstractions we'll want to think about. There is someone who initiates a transaction and someone else who responds to it. And so in this concept, we have node A, let's say that's me, an issuer, and node B, a responder. And so I am going to propose an update to the chain. I'm going to check it myself, meaning I'm going to run a flow with a particular set of arguments. That flow will trigger an update or a transaction that will then be checked on my own Corda node by the contract code, and then, assuming it is successfully verified, I, on my Corda node, will sign the transaction, broadcast it to your Corda node that will receive this information, check the update, right? Your Corda node will also validate the transaction according to the contract code. If you find it valid, then you sign it, then you send that information back to me. And then I take that and can run with it, because then I can take that response. I can collect all of the required signers. In this case, there's only A and B, but you can have many more depending on who's involved in your transaction. Then you can broadcast this information on the part of node A, right? I'm the one initiating this. So I collect all the signatures. Then I go to the notary and I say, hey, here's my transaction. I want to update this particular record or this particular state, perform an issuance, sell a car, sell gold, etc. So the notary will get this information. It will run the contract code itself. You can configure a lot of different options at this step, but we'll leave that for you to check out the documentation later if you're interested. So the notary will bring that information back to me, node A, and tell me the results. Assuming everything went well, I can record the update, and then I can tell you, and you can record the update. And then we're all done. Now this is the entire sort of process of a flow. And assuming all that makes sense to you, then we'll be able to do some pretty cool things if we start running flows and making them more dynamic to communicate between multiple machines. I'm just going to do a quick open of the token issue flow initiator and the flow tests. So let me get those right over here. Nice. Whoops. Yeah, there we go. That's what I was confused by. All right. Now, before I jump into this, I just want to do, outline really quickly. There is this concept of an initiating flow, right? But there's also a concept of a responding flow. And now we're not going to do much with the responding flow here, but I want you to be aware of what it is. And that the responding flow is the code that is run on the quote-unquote other side. You'll see that here. So the responder, there we go. Our contract tests did work. Nice. So the responder on the other side of this gets notified of a transaction that's happening, gets notified of the flow that it is going to respond to that is being initiated by someone else. And I can implement my own responder flow transaction checks here as well, implement my own business logic, etc. When I'm issuing or initiating a flow, that might have its own set of checks I want to run. And when I'm responding to one, that might be an entirely different set of things that I want to run. And that's entirely up to you, the developer, on how you want to think about this. So I'll put away the responder for a moment, and we'll just focus on the initiator, which is more interesting for us. So there's kind of 3 steps to this, and we've done 2 of them. The first thing we might do is create our token state, which we've done. And then we would build our token contract to control the token issuance. So we don't need to do that anymore since we've implemented it. The last piece of the puzzle then is going to be how do we build our token issuance transaction to actually update the ledger. And so this is where we're going to have to learn a little bit more about the actual mechanics of creating a transaction in Corda. So to start with, we are going to need the actual parties involved. And so you'll see here how we get the notary. We ask the Corda service hub to return this information to us. Then we get our own identity. This refers to the actual identity of the Corda node, which the flow is running from. Meaning you can log into the Corda shell on a node and actually trigger the flows manually yourself, just as an example. So that's the identity being referred to here. Now the next thing we're going to do is we're actually going to go and get a token state, right? We're going to just create a new one with the issuer and the owner and the amount. And in case I might not have been clear about this earlier, when you run the flow, you actually pass the owner and the amount when you run the flow yourself. And so these are specified in the constructor here for the token flow initiator. So you have the token state. We've gotten the issuer because we have our own identity. We have the owner because it was passed to us, and we have the amount. So now that we have the token state, we're going to build a transaction using it. So I'm going to create a transaction builder object. I'm going to just call it transaction builder. And I'm going to pass it the notary. There we go. So now that I've got that, the next thing I'm going to do is I'm going to create some command data. I'm going to call it commands data. I'm going to set it equal to new token contract dot commands dot issue. Now this should make sense because within the flow we're specifying the kind of command that this is, what kind of transaction this is, and so that's why we're specifying the command data is of type token contract commands issue. And we're going to just add we're going to actually explicitly tell the transaction, here's the command that I want this transaction to use, and then I'm going to just pass it the command data. I'm going to pass it the issuer dot owning key, and then I'm going to pass it the owner's owning key. There we go. Now, I'm also going to add the output state, and that's going to be the token state that we created earlier. So we're going to go transaction builder dot add output state. I'm going to go token state. There we go. Token state, and I'm going to pass it token contract dot ID. There's a few semantics here that I may be skipping over, so if you find yourself confused, I definitely recommend taking a look at the documentation. So I actually did some of this without using this, so I'm going to rip out this little piece of skeleton code right here, since we don't need it anymore. Now that we've added the output state, I'm then going to go and call transaction builder dot verify, right? And this is the first piece of the puzzle, right? We have to verify the transaction on our side. So I'm going to call transaction builder dot verify. I'm going to pass it the get service hub so that it can use the Corda service hub to get access to the different things that this method needs to verify our transaction, given all the things we've already given it. So now we give it, we've verified. Now I'm going to create a flow session. I'm going to call it session, and I'm going to set it equal to initiate flow. I'm going to pass it the owner. Nice. Then I'm going to create a signed transaction. That should be down here, actually. There we go. I actually don't need these. Sitting here going ahead. I forgot this stuff is already in here. So after that transaction builder dot add output state, there is the verify, then there is the session, and then we sign the transaction. We get a counterparty's signature, and then we use Corda subflows to fill in the rest of the gaps. We use something called a finality flow. The other Corda subflow we use here is the collect signatures flow. So this actually takes the list of every single required signer and then goes to those nodes and actually handles the process of getting all of the required signatures and achieving consensus for us. And then once we're done with that, we get the transaction notarized using finality flow with our fully signed transaction. And once again, I'm skipping over some nuance here, but if you're interested, definitely feel free to post questions in the chat or check out the Corda documentation. All of those links we will share with you guys, and you can also reach us on Slack. So more than happy to talk about this anytime. So assuming all that makes sense, we now have a fully signed transaction, and I will run into my flow tests and see if we can get somewhere. Now the flow tests take a little longer to run because these are doing a few more things. If you take a look at these within the bootcamp, you'll actually notice that we're creating a mock network, meaning we actually create a false version of node A, node B, and the network itself. We provision the network for every single test and then tear it down every time as well. So that way we can create transactions between node A and node B and make sure they work the way we expect. So let's hope this works. I'm going to go up here and I'm going to hit run flow tests. It's going to ask me for the module one more time. As usual, just select the folder name for your Bootcamp folder. I'm going to hit run. And it's going to complain to me about something I was not expecting. Port Sun Tools JStat token. Not sure what that is. Let me try it one more time. We'll run our flow tests. It may complain about the test framework. Let's see. So like I said, the flow tests may take a little while here, and hopefully we'll get lucky and it all just works. This looks like good signs. Great. So while that's going, I'll jump back into the slides and we can chat a little bit more about what's happening here. Now that we've got the flows, the notary involved, the states, and the contracts, we've actually done all of the work that it takes. We can use this kind of model to build out a wide variety of different use cases, and I'm sure you can imagine how good it can get if you're able to build anything you can imagine, right? So without me kind of pontificating here, I hope a lot of this made sense. I'm a little scared to double check my unit test because it looks like we may have run into something. So we'll see. Oh no. Alright. Let's see if we can't figure it out. Test failed, test failed. Null pointer exception. Assertions enabled. This may harm performance. Quasar Java agent. You may ignore this message. Interesting. Interesting. I doubt this is going to be solved just by us trying to run these again, and I don't want to hold you guys up with me fiddling around my strange infrastructure problems. But maybe we'll get lucky. Who knows? In any event, when it comes to Corda, you get a lot of really powerful tools, even if you have weirdness with the Java setup on your own machine, and you can use this to accomplish a lot of really interesting stuff. So, highly recommend you check it out. And if you run into issues, we're more than happy to work through them with you. You can find everything you need from us on YouTube. We have other videos and other boot camps. We have a free training site that I highly recommend you check out. You can visit us on Slack, like I was describing earlier, slack.corda.net. Invites are free. You can go onto the Corda documentation. Corda is open source, as always. So feel free to take a look at any of those things or email us at devrel@r3.com. And you can find us on Twitter as well, at InsideR3 and at Corda Blockchain. And as always, use the hashtags, #Corda and #R3. So, all that being said, thank you very much for your time. Thank you very much for your time. It's been good chatting with all of you. I hope this was helpful, and me and Peter will stick around for a little bit longer just to, make sure everyone had a good experience and see if we can answer any outstanding questions. Hopefully everything worked for you right out of the box. I tend to have strange IntelliJ